Assalamualaikum. Today we will present the answer for assignment 2 for question 1 and 2. This is the step on how to do the upside down glass or bottle experiment. Before we go further to the explanation of the experiment, let's take a look the demonstration on how to do the experiment.
For the first step, we begin our experiment with pour some water inside a glass. Ensure that the glass is fully filled with water. Here you can see that the water is full of the glass. Then get a piece of cardboard, or it could be a piece of paper, put on top of the glass. Slowly move the glass on a container, and we continue with flip the glass. Here we can see that got some air gap. It's because of when we flip the glass, some water is split out. Then slowly we move our hand, and we will see that the cardboard does not falling down.
Hello, hi. Okay, I will explain to you why the cardboard is stick to the glass and why the water from the glass not spill out. Okay, I will prove to you with the calculation. Firstly, we find what the mass of the water. Okay, we have measured the volume of the water is 120 milliliter. Okay, from the 120 milliliter is the full fill of water. After we split the water, the cup, the upside down, there has a air gap, 1% air gap. From that, we can know how many water after the flip of glass. That's why it's 1% is time to the 120 is that we got 1.2 milliliter. That 120 milliliter we minus to with the 1.2 milliliter, and we get 118.8 milliliter. The new volume is the 118.8 centimeter cube. Okay, from that we can calculate the mass of water. Mass equal to 100 kilogram per meter cube is density times with the new volume 118.8 centimeter cube, and we get the water. The mass of water is equal to 0.01188 kilogram. We look at the free body diagram. We can see they have two arrow down and one arrow ups. The two arrow down is the first arrow is force for the pressure in the water in the glass, and the second arrow for the force for the weight of the water, and the arrow go up is the force of pressure from the outside. Okay, from that we can, from the free body diagram, we want to know the pressure from the outside. First one, we calculate the weight of force. Weight force equal to mass times gravity. The mass is 0.0118 kilogram times 9.81 meter per second is equal to 0.1165 Newton for the weight force, and then we calculate the change in the air pressure. P1 V1 P1 times V1 equal to P2 times V2. P1 is the pressure inside the glass and V1 is the volume inside the glass, equal to P2. P2 is equal to I'm sorry, the P1 is the pressure before we turn the glass upside down. And then the P2 is the pressure after we turn it upside down. Okay, P1 is equal to 1 atm equal to 101,325 Pascal, and V1 equal to 0.1% before we flip up, it has the 0.1% air gap on top of the glass times with the 120 milliliter is equal to 0.12 milliliter. That is the volume of air pressure, the volume of air uh, in the glass after the upside down, the volume, V2, the volume after the turn upside down. He has a air gap 1%, and then from the 120 milliliter we minus with the 1% air gap, we can get a 1.2 milliliter of the water spill out. Okay, P2 equal to P1 V1 per V2 equal to P1 101,325 Pascal times with 0.12 exponent negative 6 divide by 1.2 exponent negative 6 and we get the pressure P2 equal to 100. We get the P2 pressure 2 equal to 10,132.5 Pascal. Okay, from the pressure 2 we want to know the force why the water cannot spill out from the glass, and then why the cardboard stick on the glass. Okay, we want to know why that's happened. Okay, and because of that we have a calculation for that. The force pressure inside the water equal to pH plus P2. pH is hydrostatic pressure. Okay, P2 and that we get before this 10,132.5 Pascal. Okay, pH equal to rho GH. Rho equal to 1000 times 9.18 is G times 0.12 is the height of the glass. Height of the water equal to 1177.2 Pascal. Okay. For pressure, for the force pressure inside the glass, the formula is pH. P pressure times with area. Okay. The pressure inside the glass is for the pH is 1177.2 Pascal plus the 10,132.5 Pascal is the pressure for P2, the pressure. Okay, after that we times with 11.31 times 10 exponent of negative 3. That is the area for the glass, and we get the force for pressure inside the water inside the glass is 127.91 Newton. Okay, after that we calculate the force pressure from the outside of the glass. Okay, outside of the glass is the formula is pressure of ATM times with the area equal to pressure of ATM is 101,325 Pascal times 11.31 exponent negative 3, and we get the 1145.99 Newton. I'm sorry. Okay, and then the last one is the force for weight equal to 0.1165.
Okay,
And we can make a conclusion. The force pressure outside the glass is greater than the force pressure inside the glass. That's why the water cannot spill out from the glass, because he has the pressure from the outside that push the water up. We can see from the calculation, we know that the force pressure from the outside is the 1145.99999 Newton. I'm sorry, is greater than the force pressure inside the glass is 128.03 Newton. Okay, that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Here I want to explain about the application of fluid mechanics in our real life. For example, our group take refrigerator as an example. We we will explain in detail about the fluid mechanic application in the refrigerator. Before that, let me explain quickly the definition of fluid mechanics. Fluid mechanics is the branch of physics that studies the mechanics of fluids and the forces on them. Mechanics of fluid like liquid or gases. It is the study of fluids at rest or in motion. It is a branch of quantum mechanics, a subject which models matter without using the information that is made out of atoms. That is, it models matter from a macroscopic viewpoint rather than from microscopic. A fluid is a substance that deforms continuously under the application of a shear stress, no matter how small the shear stress may be. Fluids tend to flow when we interact with them, while solids tend to deform or bend. We can also define a fluid as any substances that cannot sustain a shear stress when at rest. Okay, first of all, we need to know what is a refrigerator. Here, a refrigerator, commonly called as fridge, is defined as a machine which is used to maintain or keep the food materials at low temperature and prevents their spoilage. The food materials kept at low temperature spoils or degrade gradually and can remain fresh for longer time. The refrigerator generally keeps the perishable items at a lower temperature range. Here are five main components in refrigerator. First, refrigerant is a substance used in a cooling mechanism. The example of substance is isobutane, CFCs, and ammonia. Refrigerant, also called as coolant, and is the working fluid for the refrigerator. It takes the heat from inside of the refrigerator and transport it to the outside. Most commonly used refrigerant in the refrigerator are isobutane, CFCs, and ammonia. Next, compressor. The function of compressor is to compress the vapor and maintains the flow of refrigerant in the cycles. Compressor circulates the refrigerant during the working of the fridge. It compresses the refrigerant gas and increases its temperature and pressure. Compressor is the heart of the fridge. Without it, its working is not possible. Number 3, condenser coil. Condenser coil cools the high pressure sorry, condenser coil. Condenser coil cools the high pressure vapor and changes it into high pressure liquid. Condenser coil present outside at the back of the refrigerator. It has grill tube and looks like radiator. Its main purpose is to cool the hot and high pressure gases from the compressor. When the hot gases pass through the condenser coil, it gets cooled down by the cool air of the room and gets converted into high pressure liquid. Number 4. Expansion device or throttling device. This device expands the high pressure liquid, reduce its temperature and pressure. As its name indicates, it expands the high pressure liquid refrigerant and reduces its temperature and pressure. The temperature drops to 20 degrees Celsius and pressure to 0.6 bar. Last, the evaporator coil. It will take the heat from the air inside the fridge and makes it cool. Evaporator coil is present inside the fridge. It takes the heat from the air inside the fridge and makes it cool. And this cool air inside the fridge takes the heat from the food materials and lower their temperature. So that's the five main components in refrigerator. Okay, now let me explain the working principle of refrigerator. It works on the principle of thermal equilibrium. When a cold body comes in contact with a hot body, then the heat flows from hot body to cold body until they will not attain the same temperature. In the same way, a liquid, called as refrigerant, at low temperature is allowed to pass through the fridge compartment. As the refrigerants come in contact with the air, it takes the heat from it and lowers its temperature. This process keeps continue and the temperature inside the fridge lowers down and keeps the food or perishable items at lower temperature and stops or slows down their spoilage time and can be stored for a weeks or months. Okay, now how the refrigerator is working. Refrigerators work by causing the refrigerant circulating inside them to change from a liquid into a gas. This process, called evaporation, cools the surrounding area and produces the desired effect. The high pressure and high temperature, in about 80 to 90 degrees Celsius, refrigerant vapor from the compressor enters into the condenser. In the condenser, the vapor gets cooled down and changed into liquid. Okay, how condenser cools the liquid? Since the condenser coil is exposed to the room temperature, and when the hot high pressure vapor inside the condenser coil it comes in contact with room air, it gets cooled and changed into high pressure liquid. Okay, now this high pressure liquid has a temperature of 45 degrees Celsius and pressure of 8 bar and passes to the throttling device where it expands and its pressure and temperature drops to 6 bar and 20 degrees Celsius and partially gets converted into vapor. The partially converted vapor liquid refrigerant pass to the evaporator coil and it absorbs the heat from the air inside the refrigerator and completely gets converted into vapor. Here, refrigerant cools the inside air of the fridge by absorbing its heat. In the evaporator, the temperature of the refrigerant do not change. The cool air inside the fridge is used to maintain the food items at lower temperature. From evaporator, from evap from evaporator, the low pressure vapor enters into the compressor. The compressor compresses the vapor to high pressure, but as the pressure of the gas increases, it also increases its temperature, and this high pressure and high temperature vapor enters into the condenser to repeat the cycle. The cycle that is used in the working of the refrigerator is called vapor compression cycles. So that's a little bit about the working, the principle of refrigerator. That's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.